Introduction. See, Mom, that giant wheel, that is moving.
Yes, that giant wheel is in motion.
What is motion, Mom?
Motion is one of the key topics in physics. Everything in the universe moves.
How?
It might only be a small amount of movement and very, very slow, but movement does happen.
But I am not in motion.
Even if you appear to be standing still, the earth is moving around the sun and the sun is moving around our galaxy.
Mom, I want to know more about motion. Please tell me.
Okay, let's go home. I will teach you about motion.
Motion is relative to the position of the observer. For example, you can see that an automobile is moving with respect to the ground. Different observers may perceive the motion of an object in entirely different way. Or we can say that an object is in motion if its position changes with respect to an observer. A rocking chair, a swing, a bouncing ball are the examples of things that assist motion. The Earth in its orbit around the Sun is also said to be in motion. Furthermore, we provide a numeric representation for an object's location by placing it either in the positive direction or negative direction in relation to that reference point. For example, let's put a particle at x is equal to 10 meters. The particle would then be located at 10 meters from the origin on the x-axis. As you may have noticed, position is marked by some unit of length. The typical unit we will use is meters. Here the distance covered by the object is 10 meters. To describe distance, we need to specify only the numerical value and not the direction of motion. The numerical value of a physical quantity is its magnitude. The difference between an object's starting position and final position after it moves is known as displacement. Uniform motion and non-uniform motion. To understand uniform and non-uniform motion, let's take one example. Look at this table. This is the distance covered by a car A. We can see that in 0 seconds it covers 0 meters. In 5 seconds it covers 10 meters. In 10 seconds it covers 20 meters and so on. Or we can say that in every 5 seconds it covers 10 meters. It travels equal distances in equal intervals of time. Hence it is in uniform motion. Look at car B now. Car B covers 5 meters in 5 seconds, 15 meters in 10 seconds, 20 meters in 15 seconds. We have seen that the car B does not cover equal distances in equal intervals of time. Therefore, it is in non-uniform motion. Speed. Now can you tell the difference between two identical objects traveling at different speeds? Nearly everyone knows that the one moving faster or the one with a greater speed will go farther than the one moving slower in the same amount of time. Whatever speed is, it involves both distance and time. Faster means either farther, great distance, or sooner, less time. Doubling one's speed would mean doubling one's distance traveled in a given amount of time. Doubling one's speed would also mean halving the time required to travel a given distance. The rate of motion of an object can be measured by finding out the distance traveled by the object in unit time. The SI unit of speed is meter per second. This is represented by this symbol. In most cases, objects will be in non-uniform motion. Therefore, we describe the rate of motion of such objects in terms of their average speed. The average speed of an object is obtained by dividing the total distance traveled by the total time taken. If an object travels a distance s in time t, then its speed v is equal to s upon t. Speed with direction. Velocity is speed in a given direction. Speed describes only how fast an object is moving, whereas velocity gives both the speed and direction of the object's motion. To have a constant velocity, an object must have a constant speed and motion in a constant direction. It is calculated in the same way as we calculate average speed. It is given by the arithmetic mean of initial velocity and final velocity for a given period of time. That is, average velocity is equal to initial velocity plus final velocity by 2. Where VAV is the average velocity, u is the initial velocity, and v is the final velocity of the object. Speed and velocity have the same units, that is, meter per second. Rate of change of velocity. Acceleration is the rate of change of velocity with time. In one dimension, acceleration is the rate at which something speeds up or slows down. Acceleration describes the rate of change of both the magnitude and the direction of velocity. In SI units, acceleration is measured in meters per second square. It is a measure of the change in the velocity of an object per unit time. That is, acceleration is equal to change in velocity by time taken. If the velocity of an object changes from an initial value u to the final value v in time t, the acceleration is v minus u upon t. Uniform or constant acceleration is a type of motion in which the velocity of an object changes by an equal amount in every equal time period. On the other hand, an object can travel with non-uniform acceleration if its velocity changes at a non-uniform rate. Example. Let us take the example of a racing car. It takes 10 minutes or 0.17 hours to travel 23 kilometers from start to finish. We have to find the average speed and average velocity. We know that average speed is distance traveled by time taken. Therefore, average speed is equal to 23 kilometers by 0.17 hours, which is equal to 135.29 kilometers per hour. Similarly, average velocity is displacement by time taken. We can see in the picture that displacement is 4 kilometers. Therefore, average velocity is equal to 4 kilometers by 0.17 hours, which is equal to 23.53 kilometers per hour. Graphical representation of motion. A graph is a pictorial representation of the relation between two sets of data, of which one set is of dependent variables and the other set is of independent variables. In a displacement time graph, displacement is a dependent quantity taken on the y-axis and time is taken on the x-axis as it is independent. If the position of an object changes with time, it is said to be in motion. If an object has equal displacements in equal intervals of time, then the graph is a straight line inclined with the x-axis, which represents uniform motion of the object. If the graph is a curve, it represents non-uniform motion. The slope of displacement time graph gives velocity of the object. We will go through this in detail after a short interactivity. Distance time graphs. Plotting distance against time can tell you a lot about motion. Let's look at the axes. Time is always plotted on the x-axis, bottom of the graph. The further to the right on the axis, the longer the time from the start. Distance is plotted on the y-axis side of the graph. The higher the graph, the further from the start. If an object is not moving, a horizontal line is shown on a distance time graph. We can see that the time is increasing to the right, but its distance does not change. It is not moving. We say it is at rest. If an object is moving at a constant speed, it means it has the same increase in distance in a given time. In the graph we can see that time is increasing to the right and distance is increasing constantly with time. This means the object moves to a constant speed. Constant speed is shown by straight lines on a graph. Velocity time graphs. Velocity time graphs are also called speed time graphs. Speed time graphs look much like distance time graphs. Time is plotted on the x-axis. Speed or velocity is plotted on the y-axis. A straight horizontal line on a speed time graph means that speed is constant. It is not changing over time. This graph shows increasing speed. The moving object is accelerating. This graph shows decreasing speed. The moving object is decelerating. This is a velocity time graph of an object in non-uniformly accelerated motion. Equations of motion by graphical method. The three equations of motion are: v is equal to u plus at, s is equal to ut plus 1 upon 2at square, 2as is equal to v square minus u square, where u is the initial velocity of the object which moves with uniform acceleration a for time t, v is the final velocity, and s is the distance traveled by the object in time t. This equation describes the velocity-time relation. This equation represents the position-time relation. This represents the relation between the position and the velocity and can be obtained from these two equations. Let us go through them one by one. Equation for velocity-time relation. Circular motion. Uniform circular motion describes the motion of a body traversing a circular path at a constant speed. The distance of the body from the axis of rotation remains constant at all times. As an object moves in a circle, it is constantly changing its direction. Merry-go-round is an example of uniform circular motion. Satellites orbiting our Earth, artificial satellites or our moon, have motions that are very nearly uniform circular motion. The planets that orbit our sun have motions that are very nearly uniform circular motion.